Well, hey there, guys. We are going to go and look at lesson 5.4 today, this idea of dividing polynomials. Hopefully you took a look at the problem that I posed yesterday. Just a reminder of how to do long division. Probably haven't had to do that in probably 4 or 5 years. So let's take a look at the problem I gave you. The problem I gave you was 672 divided by 21, all right, using long division. So to use long division, we have to see how many times 21 first will go into 6, and it doesn't. So then I look at how many times 21 goes into 67. And I kind of look at the first number there. 2 goes into 6 about 3 times. So let me try 3 up here. And then I'm just going to come across and just double check it. So if I do 21 times 3, I get 63, all right, which is less than 67, and so I know that 3 is probably a pretty good bet here. So 3 times 21 is 63, and then we subtract those. 67 minus 63 is 4, and then I bring down the 2. All right, and then I start that process all over again. How many times will 21 go into 42? Well, I look here. 2 will go into 4 about twice. So let me check that, and then I'm going to multiply. 2 times 21. I'm going to do that off to the side here, and 2 times 21 is 42. So I go ahead and do that, and I get a remainder of 0. All right. So what we're going to do today is kind of use that same process, but now to divide polynomials. All right. So I'm going to look at the polynomial 6x squared plus 7x plus 2, and I'm going to divide that by 2x plus 1. All right. And that's 2x plus 1. I know that kind of looks like a 4 there, but that's 2x plus 1. So I'm going to see if I can follow this same process for dividing using long division to divide numbers to see if I can do it with polynomials. All right. So I'm going to look at 2x plus 1. How many times can that go into this thing? And just like I did here, I focused on how many times will 2 go into 6. I'm going to do the same thing here, and I'm going to look at how many times 2x can go into 6x squared. Or in other words, what can I multiply 2x by to get 6x squared? Well, let's see. 2 to get it equal to 6, I need to multiply that by 3. And then x, what do I need to multiply x by to get x squared? Well, x times x would be x squared. So I think 2x will go into 6x squared 3x times. Okay. Now, just like I did here, once I got that 3, I multiplied. I'm going to multiply again. All right, so I'm going to multiply 3x times 2x plus 1. Now, this is just like the distributive property. All right, so I want to do 3x times 2x. 3 times 2 is 6, and x times x is x squared. And I notice that these match up, and that should always happen. If you pick the right number here, if you pick the right, not number, but if you pick the right monomial here, these two terms will always match up. All right. Now, I'm not done multiplying yet. I've done 3x times 2x. I also have to do 3x times 1. And 3x times 1 is just 3x. Now, just like I did here, once I have that term, we subtract it. All right. I'm going to subtract here. Now again, 6x squared minus 6x squared, these should always zero out. We picked that so that these would match up and these zero out. If these don't zero out, you pick the wrong monomial here. And now 7x minus 3x is 4x. Now, just like I did here, I'm going to bring down the 2. I'm going to bring down my next term. I'm going to bring down plus 2. And then, just like I did here, I'm going to start the process all over again. How many times will 2x plus 1 go into this? And again, I'm going to focus on the first term. What do I need to multiply 2x by to get 4x? And I think I need to multiply that by a positive 2. And so now I'm going to distribute. All right, 2 times 2x is 4x. Those match up. That's a good thing. That means that I chose the right thing here. And 2 times 1 is 2. And I actually get no remainder here. All right, so this is an example, and we're going to look at several other examples here in just a little bit of what's called polynomial long division. All right, and so we see that the remainder for each of these is 0. That means 21 is a factor of 672. And it also means that 2x plus 1 is a factor of 6x squared plus 7x plus 2. We're going to look at that a little bit more closely here in just a minute. So let's go ahead and just look at another example here. All right, so I'm dividing 4x squared by plus 23x minus 16 by x plus 5. So I'm going to write that down, 4x squared plus 23x minus 16, and I'm dividing that by x plus 5. Okay, again, this thing is my dividend. That's what goes underneath the division symbol. This thing is called my divisor. It's what I'm dividing by, and it goes on the outside. All right, so again, I focus on the first terms. I want to look, what do I need to multiply x by to get 4x squared? Well, I think I need to multiply it by 4x. And now I multiply, which again involves the distributive property. So 4x times x is 4x squared. These match up. That's a good thing. And 4x times 5 is 20x. So I'm going to subtract. These 0 out, which is a good thing. That's what I was hoping for there. And 23x minus 20x is 3x. And now I bring down the minus 16. And I start the process all over again. What do I need to multiply x by to get 3x? I think I need to multiply that by a positive 3. And so now I multiply, which involves the distributive property. 3 times x is 3x. Again, those match up. That makes me happy. And 3 times 5 is 15. Now, again, I'm subtracting. All right, now be careful here. With this minus 16, I like to think of it as plus negative 16. So I'm doing negative 16 minus 15. And if I do that, I get negative 31. So here, these didn't go in evenly. I didn't get a remainder of 0. Excuse me. So just like I would normally with numbers, I'm going to write this as a fraction. All right, so I'm going to write this as plus negative 31 over x plus 5. So if they don't come out even, you don't write remainder negative 31, all right? Just like I would have here. If this wouldn't have come out even, I would have said it was 32 and 1/21st. Or 2/21st. I take my remainder and I put it over my divisor as a fraction. I'm going to do the same thing here. Whatever my remainder is, I'm going to put it over my divisor and just write that as a fraction. All right, so we've got another problem here. If you want to give that one a try, you can hit pause on the video right now. And give it a try, or you can just wait a little bit and I will solve this one here momentarily. But if you want to, go ahead and hit pause and give this one a try on your own. Okay, so let's take a look at this one. So I'm doing 3x squared minus 29x plus 56 divided by x minus 7. All right, so I start with what do I need to multiply x by to get 3x squared, and that's 3x. And now I'm going to multiply. 3x times x is 3x squared, and 3x times, again, I look at that as a negative 7 is negative 21x or minus 21x. Now again, anywhere I see subtraction, I'm going to cha-ching it. Okay, just to help me with this. That really just helps me to see this a little bit better. Now I'm subtracting, all right? So 3x squared minus 3x squared is 0. That cancels out, zeroes out, which is a good thing. It's exactly what we wanted. And now be careful here. Negative 29x minus negative 21x. If I think of this, so you can type that in your calculator, that'd be like negative 29 plus positive 21. That's going to be a negative 8x. Be careful with subtracting, especially with negatives. Don't be afraid to use that calculator. This is negative 29 minus negative 21. And now I bring down my plus 56. And I do the process one more time. What do I need to multiply x by to get negative 8x? That's a negative 8, or I can write that as minus 8. And negative 8 times x is negative 8x. Negative 8 times negative 7 is positive 56. And now I'm looking at subtracting. These zero out, and so do these. I actually get no remainder, so this one actually comes out even. So I get an answer here of a quotient, answer to a division problem, of 3x minus 8. Okay, so that's polynomial long division. Okay, now what we do with this now is to see if something is a factor of a polynomial. Is this binomial a factor of this? Well, factor means it goes in evenly with no remainder. So really all they're asking you here is, if you do long division with this, do you get a remainder of 0? All right, so let's go ahead and do it. So it's 3x to the 4th minus 4x cubed, or I might write plus negative 4x cubed, plus 12x squared. Now pause. They skipped x. Notice how they went x to the 4th, x to the 3rd, x squared. We need to put that in there, and we need to put that in there with a 0. And then the plus 5. It'd be just the same as if I said, hey, write the number 101, but you left the 0 out and just wrote it as 11. That obviously isn't the same thing. We need that 0 in there as a placeholder. And now I'm going to divide that by, all right, x squared. And again, I noticed they left out an x. So I'm going to write that in there as 0x. It really doesn't add any value to it because 0 times x is always 0, but it's still that placeholder, just like that 0 in the number 101. All right, so now we're ready to start dividing. So again, I focus just on my first term here. What do I need to multiply x squared by to get 3x to the 4th? Well, I think that would be 3x squared. Because again, remember, there's a 1 in front of that. 3 times 1 is 3, and x squared times x squared. I add those exponents together, that's x to the 4th. And now I keep multiplying. 3x squared times 0x would be 0x to the 3rd. And 3x squared times 1 would be 3x squared. And now I'm going to subtract. 3x squared, or 3x to the 4th minus 3x to the 4th is 0. Negative 4x cubed minus 0x cubed is negative 4x cubed. And 12x squared minus 3x squared is 9x squared. And now I bring down my 0x. Start the process all over again. What do I need to multiply x squared by to get negative 4x to the 3rd? I think that's negative 4x. Because negative 4 times 1 would be negative 4. And x times x squared, again, that's x to the 1st, and I add those exponents together. So that would be negative 4x cubed. Negative 4x times 0x would be negative 0x squared. And negative 4x times 1 would be minus 4x or plus negative 4x. And now I'm going to subtract. Negative 4x cubed minus negative 4x cubed, these are the same, so they zero out. 9x squared minus 0x squared is 9x squared. And 0 minus negative 4 would be like 0x plus 4x, so that would be plus 4x. And then finally, I bring down my 5. And I'm ready to do this one last time here. So what do I need to multiply x squared to get 9x squared? I need to multiply that, I think, by 9. So 9 times 1x squared is 9x squared. 9 times 0x is 0x. And 9 times 1 is 9. And now I subtract. 9x squared minus 9x squared is 0. 4x minus 0x is 4x. And 5 minus 9 is negative 4. Now again, notice they're changing the question here. They're not asking for the answer to this long division. They're just asking, hey, was that a factor? Did it have a remainder of 0? No, it didn't. All right, so no, it's not a factor. Again, in order for this binomial to be a factor of that one, we would have had to got a remainder of 0 here. Okay. All right, so again, I've got one down here. Let's take a look at this one together. It says, is x minus 2 a factor of this thing, x to the 5th minus 32? And then if so, well, we'll worry about the if it is. Let's see if it is first. All right. So again, x to the 5th. Now I notice here they skipped a bunch of x's. So I'm going to need a bunch of zeros in there. I need 0x to the 4th. I need 0x cubed. I need 0x squared. I need 0x. And then I can finally put my minus 32. But I need all those placeholders there. Again, this would be like, the number, 2,000,008. All right. I'd have a 2 and I'd have an 8, but I need all those zeros there. Otherwise, I'm just writing the number 28. And I want to divide this by x minus 2. And luckily, they didn't skip anything there. They went right from x to my constant, so I don't need to worry about filling any zeros in here. All right, so here we go. What do I need to multiply x by to get x to the 5th? That's x to the 4th. And so x to the 4th times x is x to the 5th. And x to the 4th times minus 2 is minus 2x to the 4th. I'm going to subtract. X to the 5th minus x to the 5th is 0. 0 minus negative 2 is positive 2x to the 4th. And now I bring down my 0x cubed. Start the process over again. What do I need to multiply x by to get 2x to the 4th? Well, that would be 2x cubed. And if you take a look at your answer, this should kind of follow this pattern that we go down in exponent each time. That might help you a little bit. So x to the 4th and then x cubed. I bet my next one's going to be x squared. So I multiply 2x cubed times x would be 2x to the 4th. And 2x cubed times negative 2 would be negative 4x cubed. I'm going to subtract. 2x to the 4th minus 2x to the 4th is 0. Again, that should always happen. 0 minus negative 4 would be positive 4x cubed. And then I bring down my 0x squared. Hoping I left enough room here. We might have to start squeezing together a little bit. What do I need to multiply x by to get 4x cubed? That would be 4x squared. And again, I'm still seeing that pattern, 4, 3, 2. Multiply 4x squared times x is 4x cubed, and 4x squared times negative 2 is negative 8x squared. Subtract 4x cubed minus 4x cubed is 0. 0 minus negative 8 would be positive 8x squared. I bring down my 0x. And what do I need to multiply x by to get 8x squared? Positive 8x. 8 times 8x is 8x squared. 8x times negative 2 is negative 16x. And now I'm going to subtract. 8x squared minus 8x squared is 0. 0 minus negative 16x is positive 16x. And then finally, I bring down my negative 32. I'm almost there. That's good because I'm almost out of room. And what do I need to multiply x by to get 16x? Positive 16. So 16 times x is 16x. 16 times negative 2 is negative 32. And again, I'm out of room, but I can see that if I subtract these two, I'm not going to get a remainder. I'm going to get a remainder of 0. So yes, it is a factor. It went in evenly. It divided in evenly with no remainder. So it says, all right, now write it as the product of two factors. Well, that would be x minus 2 times my answer. X to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. Okay, again, I kind of squeezed that in, but that's just my answer here. And again, what all that means is if I double distributed, did the x times all that, did the negative 2 times all that, and combine like terms, I would get that answer, x to the 5th minus 32. So to check whether or not something is a factor, you just got to do the long division and see if it comes out with a remainder of 0. If it comes out with any other remainder, it's not a factor. Now, here's the good news. This thing called synthetic division. Synthetic division is a shortcut that we can use. But here's the bad news. It only works when our divisor is x minus a. All right, so if it's x minus 5 or x minus 3 or x plus 8, because I can look at that as, minus negative 8. So it won't work if I have an x squared or a 2x, if I have anything other than x minus something, synthetic division won't work. But here's how synthetic division works, okay? So it says use synthetic division to do x cubed minus 14x squared. All right, you guys can read that. I'm not going to read it. All I write down for synthetic division are the coefficients, the numbers in front, okay? So the first thing I'm going to look, did I skip any x's? I went from x cubed to x squared to x to my constant. I didn't skip any, so I'm just going to write down the coefficients. I'm going to write down 1. I'm going to write down negative 14. I'm going to write down 51. And I'm going to write down negative 54. And then I'm going to divide this by, now notice that it's x minus a, so I'm going to look at this as x minus negative 2. You kind of do a sign change here. So when you see plus 2, I'm actually going to fill in negative 2 there. Okay, now watch how synthetic division works. I bring down the 1, and then I multiply. 1 times negative 2, and that goes here. And now I'm going to add, all right? Because of that sign change, remember normally we subtracted here, but because of that sign change, I'm kind of adding the opposite. That's the other nice reason for that sign change. So I add and I get negative 16. Now I multiply again. This is negative 16 times negative 2 is positive 32. And now I add. That would be 83. And then I multiply. And that's negative 166. And then finally I add. So that would be, let me do some quick math here. I think negative 220. So that means my answer is, all right, catch this. All right, so right here is my answer. Okay. Now again, this is the same thing. If we would have done long division, we're going to get the same answer. This is just a little shortcut we can use. So if this started off as x cubed, this is always going to be 1 smaller than that, so that's going to be x squared. So my answer is 1x squared, and then like I pointed out before, my x's just drop an exponent by 1, minus 16x plus 83 plus, and here's my remainder, negative 22 over x plus 2. So what synthetic division does is basically just focuses on the numbers. It avoids or ignores all the x's. I don't have to write all the x's down, and it's just a shortcut to do this long division. Let's do one other example together. So synthetic division, let's do synthetic division to divide these two. Now here again, notice I skipped x squared. So as I'm filling in my numbers, I'm going to fill in a 1 and then a 0 for my x squared, negative 57, and positive 56. And when I see x minus 7, I'm going to fill in a 7 right there because this is x minus a. So a here is actually 7. Ready? Bring down the 1, multiply. Add, multiply, add, multiply, and add. And so now here's my answer. If I started off with x to the third, my answer is 1 less than that. It's x squared. So it's 1x squared plus 7x minus 8. And this actually came out evenly with no remainder. So there's my answer. And again, if you got nothing better to do and want to do long division on this, go ahead and do long division. All right. And I guarantee if you do long division correctly, you'll come out with this answer. So synthetic division is just a shortcut for long division, but it only works when my divisor looks like this, x minus 7 or x plus 2. Okay. Excuse me. All right, one last thing I want to look at. I know this has been a long section, so make sure you shoot me any questions you have on this homework. But this one last thing is what's called the remainder theorem, and this one's actually kind of cool. It says if you divide a polynomial by a degree greater than or equal to 1, so any polynomial, by x minus a, then the remainder is p of a. All right, so here's what that means. If I gave you this polynomial, all right, x to the 5th plus 2, or minus 2x cubed minus x squared plus 2, and I asked you to find p of 3, what I'm really asking you to do in the old days would be, all right, put 3 in here for x and tell me what you get. Now what the remainder theorem says is, wait a minute, we can do, instead of doing that, we can do synthetic division, and whatever my remainder is would be the same thing as if I put 3 in there. Let me show you what I'm talking about. So again, x to the 5th. All right, I noticed they skipped x to the 4th, and they also skipped x. So I'm going to do synthetic division with 1, a 0 for my x to the 4th, -2, -1, a 0 for my x, and 2. And if I divide that by 3, do synthetic division by 3. Okay, no, I said bring down the 1. Let's look at it this way. Just keep it consistent. Let's add, and 1 plus nothing is 1, and multiply. Add, multiply, add, multiply, add, multiply, add, multiply, and finally add. So now what they are saying here is that if, all right, so I look at my remainder. All right, take a look at that remainder, 182. I need to, let's take a look at this and put 3 in here for x. All right, so if I go back up here and if I do 3 to the 5th minus 2 times 3 cubed minus 3 squared plus 2. Let's look at what happens when I find p of 3. All right, 3 to the 5th. Sitting here without a calculator, and that's not a good thing, but I think that's 243. Check that out for me. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3, yes, 243. Minus, this is 2 times 27. Make sure you do the exponents first. So this is 27, and 2 times 27 is 54. Minus 9 plus 2. Hey, real quick, do this for me. 243 minus 54 minus 9 plus 2. I bet you get that remainder. That's what the remainder theorem says. It says if you want to find an output for a particular input, you can put it in there. That's fine. And sometimes that might be easier for you. But what they're saying is another way to do that is do synthetic division and divide it by that input, and whatever your remainder is, that's what your output would be if you put that in there. Okay, so let's take a look at this one. You can pause if you want. Notice before you try this one on your own, they skipped x squared. All right, so make sure you fill a 0 in there. But we're going to do this one together here in 3, 2. All right, so if you tried it on your own, let's see how you did. So again, I'm going to fill in my coefficients, the numbers in front of my x's. So 1, -3, -28, a 0 for my x squared, a 5. Oops, I almost wrote in the x. We don't need to do that with synthetic division. And a 20. And I'm going to divide that by -4. All right, here we go. Add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and add. I guarantee, I'm not going to do it, but if you've got some free time and if you want to put -4 in here for x, I guarantee your answer will be 0. Your output will be 0. All right, and so that's the remainder theorem. So a lot involved in this lesson. All right, kind of an introduction to this idea of polynomial long division. Not a lot of fun. All right, but just trust me, it's going to have a purpose. Then we were introduced to what it takes to be a factor. All right, it's a factor if it comes out with no remainder. Then there was kind of good news. Hey, wait a minute. If your divisor is just x plus 2 or x minus 7, you can use this thing called synthetic division, which is a heck of a lot quicker than polynomial long division. And then finally, and this is the biggie, the remainder theorem. All right, that if I want to find the output for a particular input, I can do synthetic division with that output, and whatever my remainder is would be the same as the output if I put that input in there for x. All right, so take a look at these questions. All right, give them a try. Make sure you check the answer document. Shoot me questions you have. Shoot me ones that you don't understand. I'll be more than happy to talk about those with you. All right, good luck and take care, guys.